right. And I can go ahead and share my screen. Can you guys see my screen?
Yes.
Yeah.
Okay, thanks. Yeah, I probably have to open it again. Okay. Okay, cool. All right. I think we can begin. Thanks for joining one more for the last session. So hope you all had a good time yesterday. So there are a couple of clarifications that I wanted to make before we proceed with today's main session. I am going to throw some problems at you guys, and hopefully you guys can, stay engaged and be able to work through those problems. So I might have to pull up that question. Oh no, I think I don't need the question. So the last problem that we worked yesterday, there were a couple of things, couple comments that I wanted to make, okay? Remember that the insurance type that was given to us in the percentile question had, see a comment here, said to join in the last 2 minutes, we'll join when I get home. Anyways, okay, so the insurance type given to us was a 30-year term insurance for 30 years for life age 45. And then we were actually calculate the 95th percentile for that particular question. And we went through all the process, and what did we end up with? I think we ended up with the future lifetime being 20.8893. Now, hey guys, so here's the trick, okay? Always try to pay attention to what the domain looks like for the given question. We calculated the future lifetime to be 20.883. The question we need to ask ourselves is, does this 20 actually fall between the domain? And the answer is yes for this case. And so what we need to do is to just use the 20 and multiply by the delta value, and take the exponent and multiply by the 100,000, voila, we have our answers. Now, suppose you went through all the fancy algebra or with the help of the calculator, and you ended up getting, let's say, a 32.116, for example. That's a trap. You cannot use 32 to do your final computation. What do I mean by that? You cannot do stuff like this. E to the power minus delta times this 32.116. It's incorrect. Why is it incorrect? The future lifetime is more than the maximum future lifetime according to the type of insurance. So what's the solution? The solution would be to cap this guy at 30. So the final answer is going to be a 100,000 e to the power minus 0.05 times 30 would be the final answer. And the reason, again, to re-emphasize that would be the future lifetime value of 32.116 falls outside of the domain. From 0 t sub 45, let's say we call it 30, falls outside of the maximum number. So when that happens, you can only use the maximum future lifetime according to the insurance type. This is the trick. SOA hasn't tested this in a very long time, but there is a I think it was a 2011 question, MLC problem, that had that trick. So just be very careful when you're working these problems out, because they're definitely going to use the value 32.116 to do to come up with an answer choice and put the answer choice there at the answer choice there, which can be a trap for students who really don't understand the material. So hopefully that helps. Before we also begin, one thing that I'd like to showcase would be, I'm going to use a problem to demonstrate how I set up my equation of value before starting to save or store stuff on my calculator. Okay, just to be just so you guys can remain organized a little. So let's use the 6.1. Oh, it's interesting. I actually have a similar problem for this. Okay. So I wouldn't want to set it up, right? Let me see if I can find a very simple question. Anyway, I'll just set it out. I'll just use this problem to set it up. Not a problem. 6.5. Oops, where is it? Oh. All right, 6.1. Actually, let me just make it up because I just still don't want to set it up. So let me make it, I'm gonna make up something, an equation. I'll make up 1000 A30 colon angle 10 bar plus, for example, let's say we have V10, 10P or 30, a 40 colon angle 20 term. And then plus, yeah, I'm just making stuff up, right? So equal to, not a plus, pi a double dot 30 all the way to, let's say, 20. So the way I sort of show folks to do this type of thing on an exam is you need to be so, well, I know for sure that this value cannot be gotten directly from the live table. You need some recursion to come up with this value. So one thing I might end up doing is just write this recursion really quickly here. So that's going to be A30 minus what V10, 10P 30. And we have a whole life continuing at the age of 40. So here's what I would do. Grab my calculator, make an arrow down, call this guy an X, underline this guy, an arrow down, call it a Y. Maybe I should just use another color for this guy. And this guy, make it down and call it a Z. So on my scrap sheet of paper. So I do know that I've stored the value of A30 in the variable X on my calculator. And the black guy that is underlined is also stored in the variable Y, and the last factor, A40, stored in X. So at the end of the day, all I need to do is just the arithmetic. X minus Y, YZ. I have my final answer. When I get my final answer, I probably might have stored this in A as well. And so I'll do something on my paper to indicate that I stored this 10-year term insurance for life age 30 in the variable A. So when I go back to the main equation, I know for sure that this guy in the main equation of value is stored in the variable A. So by now you should see that this is very synonymous to Y, so it's already there, but I can still make a note. And then you probably need a recursion for the last factor as well. So write down that recursion, all the parameters that goes into it. Make sure that you are able to track where you are saving which variable. Make sure you're able to track like what numbers are being stored in which variables, essentially. These things come with practice. So I'm gonna urge you guys to um, incorporate things like this into your practice today. So just to clarify and show, demonstrate how you guys can remind yourself about what values are stored in what variables in the calculator. So hopefully that wouldn't be an issue when you begin practicing. Cool. All right. So without further ado, let's jump on into the first problem for today. Thought I had the it opened. Okay. So let's see here. I'm gonna stop sharing and share another screen. Actually, let me share the screen. Oops. I can't see. Stop sharing. Can you guys see my screen?
Yes. Yeah.
Okay. Yeah. For some weird reason, I can't see it on my end. I don't know why. Interesting. Okay. I mean, I can see it on the other screen, but it's okay. Cool. All right. So that's going to be the first problem for today. And I think for the first few questions, I might help you guys do it, and then at some point, I'll end up doing some of it with you guys and just show you how to set things up. So I think the first 5 or 7 problems or so, I might just have you guys do it by you. Okay, so feel free to give this a short. It's a 2-hour exam, 120 minutes. Ideally 6 minutes per question, but to be safe, 5 minutes per question would be. But some questions might take you a little under 2 minutes, some 3 minutes. So let's see how you guys are able to do on this. All right, so go for it. Feel free to put answers in the chat box, and Looks like we have two answers popping in from Eva and Jessica. Yep, same answers there. We'll give it about 2 minutes to see what other folks have. Any more? I think we are into 3 minutes now, going to 4 minutes. All right, so it's 4 minutes now. Since we have two answers that are the same, or yeah. So, yep, I agree. The answer choice is 0.1351. That's correct. Cool. Does anybody has any question on this particular problem? So let me stop share, then share this my iPad where I can write on the screen and just remind us some couple of recursions. All right, so yeah, I probably should send the questions to you guys prior, but yep, look, hopefully you guys captured it. So the first equation, P15, basically you were given P1525 equal 0.8108. This can be your equation number one. The second one, written in P's, you can write that as P25, 15 minus 15 plus 15 will be a 30, 25. So this would be equal to 0.2027, equation number two. Then the third equation again, I prefer writing that in terms of p's. So I have 1 minus 10p 55 would be equal to 0.222, equation number three. So since 1 and 3 are super easy, right, we need to massage equation number two a little bit. But from equation two, we can see that 15p25 fits into this guy, and so we basically can solve for 30p25. Oh, by the way, the fourth equation would be our intended equation of value. So that is p25. We've got a 30 here minus p25. We have a 40 here equal what? So this is going to be our fourth equation. Okay, so I just called it a box, and equation number four. From equation number two, we can calculate 30p25, and that would satisfy this guy right here. Really easy to do that algebra. Then the question now remains, how do we calculate 40p25? Okay, we have an extra preamble in question in equation 3. So we probably need to partition 40p25 into two different survival probabilities. And we could do that by just saying that we have p25, and since we have equation number, we have 30p25 already given to us. Oh no, not given to us, but we can find that via equation number 1. We start with 30p25, and then this dude would have been 55 years by the time. So condition on surviving up to age 55, we have 10 more years to go, right? So that makes this product we already know, and can calculate from equation number 1 by substituting into equation number 2. And then this product here can be derived from equation number 3 as well. Then voila, you have your answer choice. It'll be 0.1351. So hopefully this one shouldn't be an issue. All right. So next question. Oops. All right. So next question would be this one. So you're given the following, you have that 10-year temporary annuity due for life age 50 equal to that value, a 6-year temporary annuity due on the same life age 50 equal to that value, and you've been given 6p50 to as a value. You're being asked to calculate the 4-year temporary life annuity for a life age 56. It's just testing your recursions, and let's see what you guys get for that. Again, feel free to put your answers in the chat box. Yeah, we might need somebody to sort of talk a little bit about how he or she got to the final answer for this question, if you guys don't mind. Doesn't look like we have a potential answer yet. Anybody? Tough?
Yes, I'm kind of lost with the equations I wrote down, like how to rearrange to get the
Yeah.
answer.
All right. So let's set it up. Let's try to set it up and see. Oh, wait. Yeah, probably should just pull the 6. So it'll be. Oops. Yeah, I think I was sharing the wrong screen. Sorry. All right. So, well, I guess the argument would be, can you guys tell me what the recursion will look like? For the recursion for A50 colon angle turn? Anybody?
Would be A double dot 50 minus V to the 10th 10 P50 and then A double dot 60.
All right, so this will be 757371. Then the other guy would be, oops, supposed to be a 50. 6 would be A double dot 50 minus V6. 6P 50. We end up with what? 56, not a 60. Equal 5.13275. Then the final one, so the other parameter that was given to us is a 6P 50 equals 0.95671. Okay, so the goal is to calculate A double dot 56 colon angle 4, right, is what we need to calculate. So let's see. If we do it this way, we probably will struggle to, well, if we do it this way, then it means we need to write A56 colon angle 4. What do I, oops, not angle 4. A56 minus V4. So 4P56 A double dot 60. So this is the intended variable that we need to, or equation we need to use. So from the given information, we probably, we need to figure out what A double dot 56 would be. We need to figure out this, and we also need to figure out that, which can be a little messy. So an alternative would be, how about how about you think about recursions in a very different way? How about this? A double dot 50 colon angle 10 equals A double dot 50 colon angle 6 plus V6, 6P what? 50 times A double dot. This dude will be 56. We have 4 more years to go. We're done. This is the recursion you needed for this question. So all we need to do is to back out this dude. And we're good because we have this in the question, we have that in the question. We also have 6P50 also given to us. So perhaps in order to calculate the I, what do we need? Perhaps in order to calculate the I, okay, well, we can calculate this value from one of the equations. Possibly from, oh, you're right. So see, from this equation number 1, equation number 2, these two equations, if we subtract one from the other, right, we end up with, wait, subtract 150 would go away. Okay, so that's not going to do the magic for us. So how do we figure out the v to the power 6? Any ideas? Oh, all right. I looked at the main problem and I think it's my fault. Okay, I failed to provide what the interest rate should be. The interest rate should have been at 5%. So yeah, this is entirely on me. No way you can solve this problem if you don't know I. But this is the recursion to use in this particular situation. It would be very tedious to write it this way and try to solve things either simultaneously or do some algebra. So this recursion would be the only way to go. Did anybody get this recursion though? Anybody?
Yeah, I had that.
Okay, you had that. So the interest rate was missing. I apologize. Okay, cool.
I have a
right.
question.
Yeah, sure.
So with the interest rate being 5%, would that make us be able to utilize the standard ultimate life table for the annuities, or no, with it being?
No, the annuities were given to you in the question,
Okay.
right? So you know what? Let me just do this. I'm probably going to pull. So let me do this. Didn't I email that to myself? I think I did. Okay, so now I can pull it up one more time so it show you. So all right. So it will be this. So this is what we have. The annuities were given to us already from preamble 1 and 2 and 3. Those were provided. All we needed to do is to write a recursion, and once we have the recursion, we can plug in those numbers. So this is given, that is also given, and because we know we've been given 6P50 and we can calculate V60, V6, then it becomes a change of subject problem. Just back out this guy, and that should be the final answer. So does that help?
Yes.
Okay, great. Let's move on to the next problem. So next problem would be this question number 3. So far, we've not looked up values from any table yet. So, anybody? All right. Do we have something? All right. So let's visit the problem and see how you guys set it up. Okay. So go back to the question one more time and see. So retirement benefits for Smith and Jones, different ages, 61 and 60. Smith has a 5-year temporary life annuity due of X. Okay. And Jones has a 10-year certain and life annuity due of 20K. Now the present value of Jones's annuity is 4 times that of Smith. So you've got selected actuarial factors, and you've been asked to calculate the value of X. So first question for you guys would be, how do we set up Smith's equation of value? So let's write Smith, which is a 5-year temporary life annuity due of X. So how would we write that in actuarial notation? Anybody to?
It'd be X
Mhm.
A double dot 61, then bracket that 5.
5. Excellent. So this will be for Smith. How about Jones? How do we set that up? Let's go back to the question. A 10-year certain life annuity due of 20K. Any thoughts on how the equation of value will look like? SOA used this in tricking people a lot on the old LTAM exam, especially on the written answer portion.
I'd say
Mhm.
it's 20,000.
20K. Mm-hmm.
A double dot, angle 10.
A double dot, you have an age angle 10.
I think I thought it was just A and then 10 angle.
Oh,
Written.
okay, I see. All right, yeah.
Maybe, am
Yeah.
I wrong? I think
No,
10
no, go ahead, go ahead.
And
You want to
then-
write a full, yeah, and then
plus,
plus,
10, I mean, like V to the 10, 10 P, 60.
okay,
And then A double dot 70.
yep, A double dot 70. And that's the correct equation of value, so we need a bracket here. This is the correct equation of value. So the reason being for a certain or guaranteed annuities or insurances, right? Annuities especially, you would have the payments guaranteed for a specific period of time. And then the risk component will kick in. The risky component would be dependent on mortality, right? So for 10 years, it's certain, it's guaranteed. No mortality included in there. That makes the first term A double dot angle 10. No inclusion of mortality. Then if the person survives 10 years, we start incorporating mortality into this, into the calculation. So it becomes deferred V10 and then 10P60 to account for survivorship from age 60 to 70. And then the policy that kicks in would be a whole life annuity due at 70. So that's correct. So basically, the full equation of value will look this way. So 4x 8 double dot 61 colon angle 5 would be equal to, we have 20K times all of this times to just repeat all of that in the bracket. And then you solve for the value of x based on the parameters that have been given to you. You might have to do some algebra along the way, but I don't think that's hard to do at all. If you do that well, did I write down the correct answer? Okay, so I do have the correct answer. So feel free to go back and then work it out and confirm that matches my answer choice. 13,621.15 should be the final answer choice. Any question on the 10-year certain life annuity due for Jones? Okay, good. So let's move on to the next problem. So this will be the fourth question on some select mortality, and you've been asked to calculate the EPV of a 5-year life annuity due of 1 on a life selected at 830. Interest rate given is 6%. Try that too. Let's see. It seems to me only one person is talking today, guys. Again, feel free to, do I have something in the answer? Okay, so let's see what I've got here. Oh, so yeah, Jessica actually put an answer there. I didn't catch that. So 1362 1, yeah, that's correct. Yeah. Okay, I'm now seeing that. Sorry about that. So Eva, for this question, you had 3.5194. Let's see what others have. So this question would, it's also a good one to help you practice how to store all those ratios of the LCBX on your calculator. That way you can save a ton of time, and not having to repeat the numbers over and over again, at least twice on your sheet of paper. Okay, let's jump on into the equation of value. So anybody, so right, I have a different answer choice, just so you know, but let's see if you got the setup right. Eva, do you wanna help out?
Sure. So 830 angle 5, yeah.
Mhm.
It's the sum from k cross 0 to 4 of,
Okay, let's write out the series. So 1
okay,
plus
1 plus VP 30
VP 30.
select,
Select.
okay, plus V squared 2P 30 select, okay, yeah, sure, plus V cube 3P 30 plus 4 plus V to the power 4P 30.
Okay. Okay, great. And then, so let's write out the survival probabilities, select all without a selection, down one by one. I'm gonna write that in green. So P30 select. That should be straightforward, right? Because we can get that number from the question, right?
Yeah.
Okay, so this is okay. How about this guy?
That will be L32 over L30 select.
L32 over L30
L30
select.
select. Yeah.
Okay, all right, I do agree. And then how about 3P? How about 30 select 3?
That's also L33 over L30 select.
Okay, L30 select, okay. And then the final one would be L34
Yeah.
over L30 select. So I might have grabbed the wrong number somewhere, but you know, so
No, I
that,
made a mistake.
oh, you did? Okay,
Yeah.
okay, okay. So my answer choice, okay, for this question is 4.46255. And again, it pays to store these numbers, right? So you just store this number in variable X, store this guy in variable Y, okay, store this guy in a variable Z. And it's just a matter of just doing 1 plus X plus that, and you do the arithmetic. If you don't do it that way, you will be tempted to write down what L32 is. What's L32? So whatever the value of L32 is, you might be tempted to write that fraction, all of it down before you actually use your calculator to do that. You don't need to do that, it's just a waste of time. So hit your ratio button on your calculator, the up and the down one, put in the correct values, L32 on L30 select, whatever the ratio is, store the variable and move on and so on and so forth. Then just do the sum by calling the variables. Saves you a lot of time rather than writing stuff down on paper. I mean, writing everything down on paper. Cool. All right. So what's the fifth question? Because the fifth question is this question before I move on to the SOA problems. All right. So let's see here. Fifth question would be this one. So to clarify, I made a typo in question number 5, which is on your screen right now. The last the increase in insurance in preamble number 5, it should be an increasing term insurance, so that there's got to be a bar on top of the 50. I completely forgot when I was doing my latex coding. So just keep in mind, it has to be an increasing term insurance. So put a bar on top of the 50. And question number 5 is on an interesting concept called returns of premiums. Returns of premiums. Anybody?
Yeah, okay. The equation is, can I read the equation to you?
Sure, that would be very helpful. Please
Okay,
go
so
ahead.
the equation is 100,000 10 deferred A50, big A50 plus P times the
Can you take that one more time? 100,000.
100,000 10 deferred big A50.
When you say 10, how do you want me to write that?
10 deferred.
Oh, okay. You want to write the actuarial deferred. Okay.
Sure. 50, a big A50.
Big A50.
Yeah, plus the premium, which I represented it by P,
Okay.
times the increasing annuity of 50 to 10 is
Mhm.
equal to the same P, A that small a that's 50 is to 10.
Okay. All right. And then you are not done yet, right? Because you need to tell me what that deferred insurance will look like. So what would be this? Because
So
as
that
it
one will
is,
be
right?
actuarial
you can-
present value of 10 E50. Actual
what-
discounted value of 10 E50.
Okay, so you want me to do 10P50?
Yeah, exponent V exponent 10
V exponent 10 and
yeah, times the big A60.
times B big A60.
Yeah,
Is that it?
sure.
Okay. Let's see.
Jana,
For a special fully discrete 10-year deferred whole life. Oh, okay. Huh. I thought I made it a 10-year. Yeah, I thought okay, never mind. Okay. I think I agree. I do agree with that equation of value. So let me just explain this one more time. So these kind of problems would show up on exams like FAML, and the reason is because they've taken away a lot from FAML and moved everything to the advanced LTAM. So you need to pay particular attention to this. Before to come back to the question, and I'm glad that you know, at least somebody knows how to write the equation of value. Hopefully it's applicable to you all. So the ROPs, which is the return of premium, the principle behind this is that, well, the fundamental principle in pricing, basic pricing theory, is you need your the present value of the benefits, right? Plus the present value of all of your expenses, okay? And a benefit payment is a form of an expense anyways. This should match the present value of your premiums, okay? The premiums that are being paid. So this is the fundamental life insurance, life annuity pricing theory. So looking at this, if you read the question quite carefully, the benefit component is the benefit component would be the 100,000 would be the deferred insurance, right? 100,000 V. We've got 10P what 10P50, and we've got a 60 moving on. So that's one benefit component. The question went on ahead to say that a death benefit during the 10-year deferral period is a return of premiums paid without interest. That's also an additional benefit. And so you have to make sure you account for that benefit appropriately by putting that on the left-hand side of the equation. So, and that's something that you must memorize, okay? You must memorize this. I'm gonna show you two different versions very soon, but I'll write it as it is for now. And so we've got the missing premium P times the increase in insurance, 50p colon angle 10, and that should give us our P A double dot 50 colon angle angle 10. So again, retreating that, these two are benefits that have been included in this question. A benefit upon death and also a benefit throughout the deferral period. So to account for the appropriate premium to be paid by this person, we need to look at the return of premium benefit component added onto the benefit upon death. Okay, so the sum of these should match equivalently the premium in order for us to determine what the equivalent premium would be. Now, what you need to know for this exam, FEML, is that SOA can ask you this question in two different ways. Now, I'm not here to show you the proof, but I want you to write down the equations so you can memorize those equations. So we've got two different cases that can show up on FEML, and a third case that's likely to show up on the advanced LTAM. The reason is because the advanced LTAM would have to do with a lot of proofs. So case number one. Case number one is the ROP, the return of premium, or ROPs do not accumulate with interest. This is case number one. And so if the return of the premiums do not accumulate with interest, we can actually show theoretically that the ROP component would behave as an increase in insurance throughout the deferral period. And again, this case one is contingent on death occurring during the deferral period. This is the only prudent way the SOA can test this anyways. If they change it a little bit, you can adjust the equation of value, but conditioned on the fact that we have an additional benefit for this person if the person dies within the deferral period, then, and the premiums are being returned to this person accumulated without interest, that can be shown to be an increasing term insurance. So you have that premium pie increasing at that age throughout the deferral period end. So this would be the ROP component to be added onto the death benefit, the present value of the death benefit. So that's case number one. Case number two that can show up on the exam, and it is in one of the exam, I believe, either 15 or 18 sample question. Not quite sure which precisely, but she should be there. So these ROPs accumulate with interest at the valuation rate. This is very important. So we have an accumulation rate J given to you in the question. This must, if this is equal to the valuation interest rate I, and the ROPs are accumulated at the valuation interest rate I, then we have a different case for a situation where the person dies within the deferral period. And the way we write down the equation of value would be very different. So how would the equation of value look precisely for this scenario? This pi that can be returned to anybody would look like this. So we've got a pi outside, a double dot x colon angle n minus an annuity without mortality component at n, accounting for mortality at hx. This way, this is how you write the return of premium accumulation at the valuation interest rate. So you need to memorize these two flavors, case one and case two. You need to memorize this for your exam. Any questions? And again, the two cases I've written down, they all can be proved rigorously, but you don't need that rigorous proof for the exam. So you have to memorize the formula. Any question on case one and two? Okay, excellent. All right. Yeah, I see Jessica's put in 2264786. I think that's about right. I didn't quite write down the final answer for this. I just set it up on my sheet of paper, but that looks very, very familiar to me in terms of in terms of UFAN, my friend UFAN's manual, where I borrowed the questions from. Cool. All right, but so long as you set it up this way and you pull the correct mortality functions from the live table, you should be fine. So now let's take a detour and move into that percentile stuff. And I'm curious to see if you guys truly can solve that problem based on what we did yesterday. So I'm going to stop sharing the screen and share the other screen. Great. It would be the SOA sample question 6.45, which is question number 8 on the spring 2017 exam. For a fully continuous whole life insurance of 100,035, you're given the annual rate of premium is that. You have the mortality component to be equal to that. Debts are uniformly distributed over each year of age. The goal is to calculate the 75th percentile of the loss at issue random variable for this policy. Give it a shot. Let me check the chat and see if I've got, okay, nothing in there yet. Yeah, good job, Samuel and Jessica. I'm now seeing your 4.46. So that matches what I have to, excellent. Okay. Anybody? Oh, wait. All right, I'll give it a little bit more time to see if somebody can get this one. A couple more seconds to see if we have some answers. Okay, now let's look at the problem. Oh, I think something is here. Yeah, Morgan says give it a shot. Someone, yeah. Come on, guys.
Yeah, hello, Secret. Can I
Yep.
give the loss function? Because I'm still working it. I wanted to see if I can finish with the final answer.
Okay, that would
Okay,
be
so-
very helpful. So
Okay, so
hang on for me.
what I have is that the
Hang on,
probability of the
hang on, please, hang on.
okay,
So just hold on for me.
sure.
Might have to share the screen. Okay, let's do
Okay.
this.
So I represented my 75th percentile by the letter M.
Sure. Mhm.
So that is giving us the probability of the loss at time 0 is less than or equal to M, which is equal to 0.75.
Sure.
Yeah. Then I set up my loss function at time 0 to be equal to
Okay.
the 100,000 big A 35 bar. That is the continuous function of big A.
Big 8, 35.
5 bar. That is continuous.
Okay.
Yeah. Minus the
let me-
premium, which
let
is
me stop you.
560.
Let me stop you. Big A with the bar and the 35, that's not a random variable. That's a number.
Oh, okay. Sorry. I V exponent T35. That's what I mean.
There you go. There
Yeah,
you
that's what I actually mean.
Okay. So go ahead. So V to the
V
power
exponent T, big T35.
big T35. There you
Yeah,
go. That's a
minus
rendezvous.
560, which is the premium.
560 is the premium.
Yeah, bracket open.
Sure.
Yeah, 1 minus V T35, V exponent T35. Yeah, all over the delta.
Sure.
Yeah, so that is what I put in there, and I'm sorry for the
Okay.
N. Yeah.
Excellent. All right. Yeah, I'm happy that you were able to give the correct loss function. So now let me use this question, take advantage of this to explain the concept one more time. So 6.45, scroll up, look for the problem. And what we did yesterday was a very simple version, if you remember. It was just a term insurance on which we calculated the 95th percentile. Where are you? There you go. So, and again, the question for this is a continuous whole life insurance. So that makes life really easy. Premium was given. Mortality follows the standard ultimate life table. Deaths are uniformly distributed over each year of age, and I is 5%. And again, if I may ask, why is UDD important in this question?
Because of it's being continuous whole life, we can use UDD to transform discrete to continuous.
Excellent. That's the reason, flat out. Good. So, given that, given what we learned yesterday, remember yesterday I started getting really technical with how monotone a function is, and we ended up with a shortcut. I just want to reiterate that one more time. So, I mean, just like we know in college, we learned about different types of functions, right? A function can be, we did limits and continuity of functions in college. We learned that if a function is continuous at a point, then its limit exists, and vice versa. If the limit exists, then the function is continuous, sort of thing, because they must both match for that to happen. And there are two types of function. A function can either be monotonically decreasing or monotonically increasing. So there's a shortcut to these problems. You don't have to think a lot to do anything, if and only if you understand the shortcut. Now, recall for yesterday, we set up the Z to be, Z was V to the power T45. Z was less or equal to T45, less or equal to 30. We have 0, nothing is paid if the person survives the 30 years, right? And so, well, otherwise will be T45 greater than 30. What did we find out about this question? We found out that for the 95th percentile to occur, well, actually, we found out that this function is monotonically decreasing within the interval range of T sub 45. What does that mean? That means that T45, if we choose a value of 0 from the domain and plug it in there, we go next. Oops, actually should just do a 0. Let me clean things up a little bit so it wouldn't be too messy. So V0 to the power V1, and we go on V2, we'll notice that these numbers would be decreasing as one increases. So this guy increases, we increase these numbers, right? The V's would rather decrease. And the V's are the output. So the function is monotonically decreasing. So we learned two key insights yesterday. If the function is monotonically decreasing, the shortcut is we only need to find the future lifetime that maps exactly onto 75%. So in this case, yeah, if it's monotone and monotone decreasing, right? If it's monotone decreasing, it would map exactly to alpha percent. But if the function is monotone increasing, this would map exactly to 1 minus alpha percent. It is very important to understand this. So if you go back to this question, what we need to ask ourselves is the loss at issue random variable that was given, is it monotonically increasing or decreasing? So if we can answer that question, we are safe, because then we'll know that we need to find that little t that maps onto alpha percent or 1 minus alpha percent. Because if we don't understand that component, it will be very, very difficult. So the question now that I pose is, given this loss at issue random variable, do you think this loss random variable would be monotonically decreasing or increasing? If you choose values between, this is a whole life insurance, so from T sub 35 all the way to infinity. If you pick different values and substitute into this, would it be increasing or decreasing? You can eyeball it really easily.
It's decreasing.
It's decreasing. Excellent. So if it's decreasing, then we know that we only need to determine the future lifetime random variable that maps exactly onto alpha percent, which is 0.75 in our case. So without writing it, your loss at issue random variable is very important. Write that down and figure out whether it's monotonically increasing or decreasing. And then you know whether to map it to 0.75 or 0.25. So since we already know that this is decreasing, all we need to do is to determine our TP35 should be at least 0.175. We begin. This whole part is a 2-minute process with the help of the calculator. So let's begin. L35 plus 4t over L35 is at least 0.175. And the next step will be L35 plus 4t should be at least 0.175 times what L35. Who can give me the value for 0.75 times 35 times L sub 35? I'm waiting for that. L sub 35 plus t is at least. So look up L sub 35 on the live table and multiply that value by 0.75 and give that to me.
Seven four six six seven.
74667.
667.525.
0.52. So let's stop there. 0.525. So 0.53. We can stop there. Great. So what do we do next? This is where we need to take advantage of UDD. In order to determine, so the question, the high school question to ask is, what is the value of t that makes this inequality possible? And in order to do that, we need to go back to the live table, identify L sub 35, which of the ages, sort of sandwiches 74667.7.5. So let me do that and see, do I still have my live table opened okay, I do. So we have 74667.5. So when is 7.4? If I keep scrolling down, this should be between, it should be between ages 80 and 81, right? Ages 80 and 81 should contain that number. So let me write it down really quickly. 80 maps to 7.2, and 81 maps to 186.3. Okay, so we have 80, 81. So let's go back. So we have 80, the point 80, 75, 657.20. That's our first point. And the second point is 81, 73186.30. So these are the 2 points we need to do the linear interpolation. Remember, the UDD concept is just a linear interpolation. What does a linear interpolation mean? Linear interpolation simply means perform a linear regression. That's all. And we learned yesterday that we can actually use the calculator to perform a linear regression. And when we write that linear regression, the question is, y equal mx plus what c? What are we looking for exactly from this linear equation? We do have, if this x, if the ages are our x, and the survivorship cohort, the L sub x, are the y, the L sub x represent our y, y here, then the high school problem that we are trying to solve by fitting a linear equation is to look for the value of x that produces a value of x conditioned on a certain value of y. Remember, I explained yesterday that a linear regression is basically the expected value from exam P of x, because from this equation, x is known and the covariate x determines the value of y. But in this context, we rather need the expected value of x conditioned on y, because we know what the y value is. The y value is a 74667.53. So can you guys use a calculator to determine what to determine 35 plus t, right? Whatever you do, what you are doing, or you do on the calculator, that answer would be 35 plus t. So we need that answer on your calculator. Take a difference between that number and 35 to find the future lifetime. So can anybody try that? Try that using the calculator. It's just a matter of using the data function. So if you don't recall that, you might want to watch yesterday's video, but if you go to data, you have on your L1 column, type in 80 and 81. And then in your L2 column, you have 7.20, hit enter. The other number corresponding to 81 will be 73186.130. Use the statistics worksheet, right, to extract the parameters. Wipe the screen, second quit, and second start again. Go back to the second variable, and then this time around, look for x prime. X prime on the calculator means the expected value of x conditioned on the fact that you know the value of y. So you do x prime, parenthesis, 7466, 7.53. That should spit a number for you. What is that number, guys? what I mean here, when you go to your data, you hit the data button, L1 and L2. You've got 81 and you've got, was it 81 or 80 and 81? So you have 80 and 81, put in the values, the corresponding values, right? What do you have on the screen?
80.4005.
Thank you very much. And that is 80.4005. Excellent. So now we know that 35 plus T, that number, remember that the UDD guy we are fitting on the calculator maps to 35 plus T. That is what maps to 7.53. So that age on your calculator should be 35 plus T is equal to 80.4005. What is the future lifetime of this person? 80.4005 minus 35, and this would be equal to 45.40. So, I was looking for, okay, so what's the final answer? We're almost there. The final answer would be to go back to the loss at issue random variable in here and do what? Plug in that 45.400 in here. That value is the 75th percentile of the loss at issue random variable. Can anyone try? And tell us what that value is.
It would be 690.
It will be 690, and that's correct. So if we go back to the questions right now, go back to, where's the question? Yeah, oh, these, yeah, not sure why. Oops. I want to hold this guy and drag it down to 645. All right, so 690 is answer choice E, okay? So that's the 75th percentile. If you practice this, it's just 3 minutes, you are done. Really, really quickly, because number one, you know at the back of your mind, I need to write down the loss at issue random variable for the policy. Once you write that down, you need to figure out, is it monotonically decreasing or increasing? Because that would help you to determine whether to do TPX at least 75 or 25. If it's increasing, it's got to be 25. If it's decreasing, it's got to be what? 75. It'll map onto the exact same percentile given to you. Once you figure that step out, everything else is just like a 1 to 2 minute work. You are done with the entire work. So this is a 3-minute exercise. But if you really don't understand the material, you can use a really long approach that can be daunting on the test. I'm curious how the SOA solved this problem, really. So I'm going to navigate to the solution. Let's look at how the SOA did it. Oops. So 44. Okay. Okay. So as usual, SOA wrote down the loss at issue random variable. Yes, we agree that's correct. And then they said, since L sub 0 is a decreasing function of T, the 75th percentile of L of T is such that that guy is at least 75. So, okay, so they're following the same logic as we did, right? Looking at whether the function is monotonically increasing or decreasing. And then once you figure that step out, blah, 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 it's virtually the same. Okay, so this time around, the solution looks pretty similar to what we did, unlike yesterday. But the question is whether or not folks can do the intermediary steps and end up with the 45.40. You don't have to waste a lot of time, just use a calculator to do it, because you pick those numbers from the table and then you just apply the UDD, perform the UDD by using the calculator. That will give you that value. Then you can do the subtraction, end up with that 45T, and go back and plug that in. You're done. Cool. So hopefully you guys, when you get this question on your test, you will not let this skip. You'll grab the point. Okay, cool. I think I've got a problem here for you guys. Question 6. Wait. Oh, so a 10-year deferred whole life. Oh, 10-year deferred, 20-year. Okay, great. All right. So this will be a really good exercise to see if you guys understood the 2 scenarios I gave about the ROP. And again, I think I made a typo in my LaTeX scripting. The 5th preamble should be a term increase in insurance and not, so there's got to be like a bar on top of the 40 to represent a term increase in insurance. So give it a shot, because this time we've been given an annuity due, unlike before we had a whole life insurance, but this time around we have an annuity due, but they've given a flavor to this type of annuity. So I'm curious if folks can write on the equation of value. Oh, and the return of interest, wait, paid with interest at the end of the death. Did you fan make a typo with this question? The death benefit during the 10-year deferral period is return of premiums paid with interest. That cannot be with interest. You don't need to give that increase in life insurance. So I may be using an older version of the manual and not the updated one. Yeah, that cannot happen. So assume that the premiums are returned without interest. I know it's scheduled for 3 hours really. So after this problem, we'll take a 10 minutes break and we'll talk briefly about the statistical components like the Kaplan-Meier, the Nelson-Allen, and how to use the maximum likelihood. Possibly not solving a bunch of questions there, but just to point out certain pitfalls. I haven't worked this problem, so I'm curious what folks would get in terms of final answers. So I'll be counting on your solutions. If we get 2 or 3 matching, possibly that would be the correct answer choice. So we'll see. Let me check the syllabus one more time to make sure that. Um, FAML. Anybody? So Jessica says it's 990.38. Do we have anybody matching Jessica's solution? Okay, well, Jess, do you mind giving us the equation of value?
No.
Sure.
So started with 1,000 V10 10P40 A double dot. Small a annuity due. 50 angle 20 plus P, the real P for the premiums, increasing annuity, term insurance from 40 to 10
40 to 10, yes.
equals P A double dot 50 angle 10.
Let me be sure about the question. So for a special 10-year deferred 20-year life annuity due on 40, the death benefit 10-year deferral, okay, 20-year. So Jess, do you see where the problem is? It's a 10-year deferred, 20-year life annuity, right? Wait.
I think in the problem it says that the premium is paid during the deferral period. So that's why I hit A double dot 50 10.
Oops. Annual premiums are paid. Okay. Are paid during the deferral period. So that cannot be 50-10, has to be 40.
40-10. Okay, yes.
Yes. So we have a 40-10 right here.
Okay, yeah, then that would change my answer. 'Cause I accidentally put 50.
But that's the, yep, but I agree with the equation of value. That's it. So it's very important. Once you clearly write that down, you should be good. And then you can begin to do stuff like mark this guy. This guy is 10E40. So make an arrow, store in a variable X. Let me use purple. This guy can be gotten directly, make an arrow, store the value in that. This has been given to you already. If you still want to store it, you can do that. And then this also you can be figured out. So maybe store that in a variable A and store this guy in Z or something. Then you know how to play around to find the value of P. Really easy. You could even move this dude all the way to the other side and factorize P out, so you know what difference you have to take to divide by the product of X and Y. So mechanics like that, try to be very smart on the exam and not be repeating yourself on paper, because you don't want to write 1000 1.05 to the power -10, and then you look at the live table, whatever the value of 10P40 looks like for you, possibly folks are going to do L50, L50 over L40. Oh no, that's too long. Then they'll write down this value as well. No, it's too long. You should by now know that this guy here can be gotten directly from the table, and that's 10E40. So some of these things really help you save a lot of time. Because if you're going the long approach, then L50, possibly you're going to be grabbing numbers on the table. If it's 99990, for example, divided by that, okay, you end up doing a lot of repetitions, and that doesn't help when, from the standpoint of efficiency and your time management, it's just not the best or the efficient way to work problems on this test. So very cautious about repeating yourself. And what that happens, just know that you can store the variables in your calculator instead. Okay, good. Let's take about maybe 10 minutes. Yeah, 10 minutes would be good. So it's exactly 6 p.m. on my end. It's 5:59 actually. Let's take a 10 minutes break. Come back and talk about the parametric and non-parametric estimation. Cool. So see you guys 6:10 my time, 7:10 your time. And I'm around, so just in case you want to chat, feel free to let me turn on my video now, since the presentation is good. So if you want to chat, feel free to chat about FAML. How do you guys feel for prior to the exam though? Feel good about it? Anybody want to share?
I feel okay. Yeah, I feel pretty good, but I'm actually taking the FAM exam, so I'm taking both FAM S and L combined. So, yep.
How's the S going?
S is going pretty well. I think it's just, making sure to pay attention to the details of the questions and, making sure the setup is correct.
Yeah.
Wow. Me and Jessica falls in the same boat.
Oh,
And,
you guys are doing both. Cool.
yeah, I'm just trying to round up some of the chapters in Farm L, and I'm good with Farm S, but the Farm L path, I'm just trying to wrap it up and get going, just to be fully confident before the D-Day.
That's good to hear. Yeah, I noticed that the pass mark for FEML was about 75, 75 or so percent passed the exam last sitting. So you guys will be fine. Yeah, it's an easy exam. You just have to make sure that you know your recursions very well and you've memorized enough, and you should be fine. And understanding really counts too. Yeah, I think. Cool.
I don't know, Jessica, when are you writing?
I am writing it on Monday, March 6th, so a
Oh.
week from this Monday. How about you?
Oh, I'm writing on the same day,
Okay,
first thing in the morning,
same thing. Me too.
7:30 thereabout.
Yeah, where are you located?
Okay, I'm at Normal, but I'll be writing at Urbana Champaign.
Okay, nice. I go to Georgia State University, so I'm sitting in an Atlanta Prometric Center.
Nice.
Have you taken practice exams, Samuel?
Not yet. How? But I've solved a lot of the questions, like the sample questions. I've solved as much as possible. But I'm trying to wrap up the last chapter of Farm L. That's the aspect of premium and policy value calculation, similar to what we are doing right now. I'm just trying to cover it up so as I can then start. So I started studying that's in January.
You should be fine. It's not a hard exam at all. Not at all. You should be fine. Yeah. Yep. So don't worry. Cool. Yeah. Any one of you started the modules yet?
I haven't, but I think after this exam, I want to start modules, because I know I thought of taking SRM after this exam, but that would be a very short time window because SRM is the end of May. And I'm a junior in high school, so I have other responsibilities. So it may be tight to do that along with finals and whatnot. So the next sitting for an exam would be in the fall time. So I wanted to, start modules so I can, make some progress within this time before I sit for a different exam.
Good.
I'm not really sure how they are structured though, because I haven't heard much about how it is. Do you feel like, is it just kind of like a online course you take with a test at the end, or?
Right. So yeah. So, not sure if it's changed, but there are 8 different modules basically within the FAP. And then if for each one of them, you have close to about, well, between 100 to 200 slides to review. Once you're done reviewing those, there's an end of chapter or end of section or end of module exercise. Actually, let me back up. EMA. Okay, well, yeah, exercise would be a correct word to use. So there are end of module exercises you have to do just based, to make sure that you are able to, you went through the material and can answer some questions. When you're done with that exercise, there's an assessment you have to complete within 96 hours and submit to the SOA for grading. So, and out of the eight modules, you have to complete 4 assessments within 96 hours, submitted to them, and they would grade. And once the grading is done, they will post on your transcript. After the final module, which is the 8th one, there is a final assessment you have to take. That also has to be completed within 96 hours. And once you pass that, you're done with the entire FAP. So yeah, but.
And then with those modules, with those exercises and assessments, is it an open notes?
It's open notes. Yeah.
Okay. So do you
Yeah.
feel like those are not, you like it's not difficult, the modules to complete?
Yeah, it's super easy. So I always tell folks to start right after first passing 2 exams. Start on that. It helps you to also practice your writing, which is very key for this profession. So yeah. But it's open book. You can look at the internet and cite and reference stuff. But yeah. Yep.
Thank you.
Cool. So we've got about a minute to do some other reviews. Excellent. So I'm going to share the other screen and do a review. The review is, let's look at the female syllabus. I'll toggle between the syllabus and the table. So be sure that you are able to go through the FEML, the syllabus to convince yourself that you've covered stuff. But if you're using TIA, coaching actuaries, you actually don't need to do this. But the thing I want to point out is that the first 1 or 2 questions or so is always going to be qualitative. They would ask you really non-quantitative related questions to test your understanding of the material. Basically, did you really read? Do you understand some of these insurance coverages? I see they put retirement financial security programs here. So you've got to know the difference between the 2 retirement plans that we have, the DB and the DC plans, right? The defined benefit pension. Oh, actually, it's right here. So we've got defined benefit and defined contribution pension plans. You should know what what the differences are. Annuities, health, and life, that should be okay. Those are long-term coverages. But I think the new thing that folks has to pay attention to would be DB and DC, right? You at least should know the differences between the DB pension plan and the DC. With a DB, the firm or the company sets up the pension plan for the employees out of the company's own coffers, right? So the employee doesn't have to pay for that. It's like if you're earning, let's say, $80,000 every year, the firm chooses to apply about 2% of that $80,000 and then allocate that into a fund that grows with interest for you. You don't pay that. They take care of everything for you. With a defined contribution pension plan, just like a 401k and 403b, the employee would have to make regular contributions into the fund. So the key difference between the DB pension plan and the DC pension plan is, with a DB, the employer assumes the mortality and investment risk. But with a DC pension plan, what happens is that since the employee determines how much money he or she needs to contribute out of the paycheck, the monthly paycheck, you're basically assuming your own mortality risk and you assume your interest rate or investment risk as well. That's a key difference between these two pension plans. There are some other matching concepts in DC, but I don't think that would be on the syllabus, like your employer telling you that, I know you choose how much money you pay out of your paycheck every month, but if you can contribute 6% or a certain percent and above, I would match it by 3%, 4%, or 5%. So if you're contributing $1,000 into your DC or your 401k, the employer can just say, okay, because you're exceeding that 5% or 6% threshold, I'm going to match it with $400 every month. So essentially what goes into your 401k at the end of every month would actually be $1,400 and not just the $1,000. So there's a matching concept there. But what do you really should know should be the difference between the DB and the DC. Let's look at mortality tables. Understand parametric survival models, life tables, and their relationships, those recursions, right? Know how to use the second point, the different types of mortality functions, right? Force of mortality function, how to do curtate and the complete life moments, right? Those you should be able to calculate, summing up the survivorships, and so on and so forth. If it's curtate, you're summing. If it's a complete, you're doing integrals. Identify and apply standard actuarial notation for future lifetime random variables, moments, including selecting ultimate functions. We looked at an example like that, so that should be fine. Then we move on and say, identify common features of population mortality curves. That should be embedded somewhere in the actuarial mathematics and life contingent textbook, I believe, but not particularly sure what they mean by that, but I don't think that will be that significant. Parametric and non-parametric estimation, 5 to 10%. The goal is the candidate will understand and be able to estimate parameters for parametric and non-parametric survival models. You should at least know how to apply the maximum likelihood estimation to estimate the log likelihood functions for various laws of mortality. So even though I doubt they might test that directly, they could, but it will be very simple, right? This would just be like the FAM-S type of thing, where you have your survival model and you have some data set, then basically you can find the likelihood function, take the derivative of it with respect to a particular parameter, set that to equal to 0, evaluate what the optimal parameter would be, and that gives you your maximum likelihood estimation, right? So they can give you any really basic mortality curves, like gum pads would not be given. It would be too tedious to do that. So some exponential or some really basic mortality law to do that. To apply the Kaplan-Meier and Nelson-Allen methods to estimate empirical survival functions using censored and truncated lifetime data. This should be super easy, right? And so do we have the formulas here? Let's see. Okay, we do not. So you just have to know how to estimate. You have your numbers that survive divided by your RI, the S sub I divided by your RI, but you have to know how to do it for both. Where are you? Oh. Wait, right here. You have to know how to do it for the Kaplan-Meier and the Nelson-Allen. Those are like really easy stuff to do. You have some table and then you do all those stuffs. You calculate the approximate standard errors of the parameter and probability estimates. I probably will touch on that a little bit. And construct linear and non-linear confidence intervals for parameter estimates. Linear is easy. The non-linear would be the log transformed versions. You just have to memorize those. I will show you guys. Wait a minute. Where is? I'm gonna use my friend's notes. Yufeng. Okay, so if I skim through this, Yufeng, where are you? Kaplan-Meier, Nelson-Allen, so AMLCR third edition. So let's go there and see. So I'm actually looking for log transformed and the linear confidence intervals. Nelson-Allen, there you go. Greenwood approximation, linear and log confidence intervals. So the formulas for the Kaplan-Meier and the Nelson-Allen are given to you. For example, if you look at the table, the Greenwood approximation formula is given right here. So to calculate that, you only need the R sub J and the D sub J stuff, and you just look at that. So just make sure that you're not spending time, don't spend time to memorize these, right? Just do not, because they are already here. Most students don't know the formulas are here, and so they tend to memorize it and end up either skipping, like when calculating the variance, for example, they might just end up missing the square of this S sub T, and that can be a problem. For the estimated variance for the Nelson-Allen estimator, for example, the denominator has to be an R cube. That's very important. Folks can make a mistake and make it R squared instead. But again, these two formulas are there, so you don't have to memorize them. Just look them up and then use it for your stuff. So, okay, yeah. So let me unshare and then make a quick note on confidence intervals on my iPad. So the common pitfall here is you estimated S sub T at time 3. Or SOA just gave you this number in the question and asked you to calculate the 95% confidence interval linear. Well, so if you're silent on confidence interval, right? then that's just linear. But if they want you to use the log transform confidence interval, SO will be very specific on that. So you've been given this estimate. The goal is to find the 95% linear confidence interval. So what you need to do is S of 3 plus or minus, you have your Z sub alpha over 2 and the square root. I'll just say the standard error. Yeah. So what's the common pitfall or trap? You've been asked to do a 95% confidence interval. Who can tell me what Z this will map to? There's a factor that corresponds to 95%. What's that?
1.645.
1.645. Okay, who else?
1.96.
1.96. You see, this is where the confusion lies, right? This guy is the correct guy to use. The reason is because in statistical theory, we do something we call hypothesis testing. When you're testing a hypothesis, the researcher is interested in whether the parameter estimate is accurate or not. So the null hypothesis becomes S sub 3 is equal to some value. Let me not use alpha. Let me use gamma. And then the null hypothesis becomes S sub 3 is not equal to this gamma guy, right? So when you're doing this type of hypothesis testing, we call it a two-way hypothesis testing, because then the alternative looks at two different directions. It looks at whether not equal to means less than or greater than. And in fact, less or equal to or greater than or equal to. This combined makes not equal to. So if you're interested in not equal to, it becomes a two-way hypothesis testing. But suppose that then the alternative is just S sub 3 is let's say less than, okay, let me write that well. It's less than this gamma guy. Now, this would now be a one-way hypothesis testing. And this dude here would be two-way. So when you have 95%, well, the keynote is the log transform confidence interval that you do and the linear confidence intervals, those are in reference to a two-way hypothesis testing. And so 95% would map to 1.96, right? Actually, let me, we've got, so we have 95%, 90%, and I think there can be an 80% or something. 95% would be a 1.96, 90% would now have been a 1.4645. I believe this guy will be 1.282, but I don't know. But we'll see. Let's see. Let me unshare and look at the. So let me share. Look at this. Oh. All right, so let's look at the, there you go. Okay, so look here. So you see, 95% corresponds to 1.645. That's according to the table. That's according to the standard normal table. I'm going to show you how to transform that into a two-way hypothesis testing. Okay. Yeah, Naya, I got that right. Okay. So when you've been asked to do a 95% confidence interval or log transform confidence interval, because it's going to be a two-way hypothesis testing, you move on to the next guy. It's going to be 1.96 that would be used, because that two-way hypothesis testing would now map to 97.5%. I'll show you how or why. So if the question changes to perform a 90% confidence interval or a 90% log transform confidence interval, it becomes 1.645 in this case. You move on to the next, it's going to be a 95%. I'll show you how to derive that. And then the last one would be, you've been asked to do as 85%. You move on to this guy, it's going to be 1.282. I got that right. So let's see how to derive that. So let me stop sharing and go back to my iPad. Sorry, I've been toggling around here and there, but so a 95% confidence interval, we understand according to actuarial mathematics and life contingence test, the textbook, the analysis they drew in there is for to test the parameter estimate using a two-way hypothesis testing. And so the way to derive the appropriate Z alpha on 2 would be 1 plus 0.95 divided by 2. This gives you 1.95 over 2. And if you use your calculator, this is 97.5%. And this 97.5% is the value 1.96. So this is for 95%. Next, let me zoom out, zoom in rather. Next, 90% confidence interval with a linear or log transform. This Z 0.9 on 2 would be 1 plus 0.9 all on 2. It's basically saying that do a continuity correction by adding 1/2 to that. And if you do this, you're going to be having 95%. And this 95% maps to 1.645. So all of the folks taking the S, take note of this, because all of that is going to be a two-way hypothesis testing as well. And so you could do the same thing for 80% and 85% and then find the values. But the common ones would be 90% confidence interval or 95% confidence interval. The only trap there is folks get confused or just don't know what Z alpha to use over there. It's very different from looking up a number from the standard normal table. This type of question is in relation to hypothesis testing. So you don't just look up numbers on the table. You need to do a little bit of a transformation by adding 0.5 to half of those confidence interval value that will be given to you. So that's a common pitfall that I wanted to call out to you guys. Memorizing the formula is not too hard, so we should be good. So going back and sharing my screen. So now we have. So we've looked at that, and so the 10th one would be present value random variables for long-term insurance coverages. So essentially what you're doing here is So the candidate will be able to perform calculations on the present value random variables associated with benefits and expenses for long-term insurances. So the gross premiums, you have some expenses thrown into the question. You'll be asked to calculate the annual gross premium, and so on and so forth, to set up the equations of values, and you determine those appropriately. The pitfall is when the SOA gives you monthly or quarterly or semi-annually, students get confused. And again, you need approximations to carry this out, which is why we've got fractional ages and the claims acceleration approaches here. Okay, I guess let me go back and just see if you guys can recall some of the UDD relationships related to annuities and insurance. For annuities, you will be asked to do Woolhouse's formula calculations a lot. But for the insurance is like it's typically going to be a UDD, but anyways, but assuming UDD, what is a bar 40 going to look like in a discrete world, assuming the UDD? Who can tell us?
Would be I over delta discrete A40.
A40, excellent.
Hello, my
How about a bar 40 colon angle angle 10? What will this look like in a discrete world?
I over is it theta
Delta.
delta A40 plus
A4. Do you want to do plus, or it's an endowment?
A40 10
A40 10
term insurance
term insurance, correct.
plus 10 E40.
Okay, it's gonna be this, right? Be very
Yes,
careful that it has to be the sum of pure endowment and the term insurance.
I
What's
think
the
it's the same thing as 10 E40. Is that correct?
Oh, you said E40. Yeah, you're right. 10 E40. That's correct. That's correct. Yes, that's correct. What's the pitfall? Do not apply any factor on the pure endowment component. Why? It does not depend on mortality. It's contingent. The payment is certain for 10E40. So do not account for that by multiplying through by I over delta. Do not. Okay, not supposed to be done. Now let's go to A upper M X. What would this look like applying UDD?
I over IM AX.
I over
IM
IM
AX.
AX. Excellent. Good. Now, okay, let's continue. How about yeah, so if you know that, then if you've got a term insurance like that, it's definitely going to be something like this, right? Colon angle N. Then you account for that. Question for you. Do you know that, okay, not actually a question, right? But just to remind you of something that can save you a lot of time on the exam. Let's go back to the table. The table has interest rate functions, guys. Do not try to be calculating I upper M by yourself. It's a waste of time. Many students don't know that these interest rate functions are already here. So I over I upper M is already in this column. You have it here. Just pick whatever it's being given to you. In SOA, it's going to give you 5%, but verify that you have 5%, obviously. You do have I upper M also given to you. So just if you know the formula on top of your head, you're okay. But if you do not, please just remember that these are on the table. Just look them up and apply those factors. Don't stress yourself. And these can be like storages on your calculator. Cool. Woolhouse's formula. SOA is generous to give us the 3-term Woolhouse formula in a single decrement context. What that means is that we're talking about an alive to death model. Please, memorizing this can be something. If you can memorize it, please remember that this is on the table. In fact, I never advise any of my students to memorize this because it's already on the table. In essence, please familiarize yourself with the table and be sure you know what items are on the table and the things you can memorize, things you don't have to memorize. Based on the 3-term Woolhouse formula, who can tell me how the 2-term Woolhouse formula would look like?
It'd be a double dot X minus M minus 1 over 2M.
That's it. You ignore the third term. That's it. You're done. So if you know that the 3-term Woolhouse formula is already on the table, you don't even have to memorize the 2-term, even though that memorizing that is super easy. But just remember, ignoring the third term gives you the 2-term Woolhouse formula. And again, it's here. Don't be don't try to impress anybody. So, okay, cool. What else have I got on the table? Reminding you that 5EX is on the table, 10EX is on the table, and 20EX is on the table. Please, it can save you a lot of time and you don't have to be doing calculations by yourself if you remember that these are already on the table. So you can apply them in mapping using the equivalence principle. You have your present value of benefits or the actual present value of benefit plus the APV of expenses equal to the APV of the premiums. If the product is of a 20-year product or a 10-year product or a 5-year product, SOA, they usually construct questions in such a way that you can look up values really quickly from the table, and understanding what's on the table is really, really, really important. So I think from a table perspective, we have everything covered, pretty much everything covered on the table. What else can I talk about? Effective changes, and that's just actuarial knowledge and mortality and interest. Identify and apply standard actuarial notation for the expected values. Okay, that's very typical. And all of this equivalence principle and portfolio percentile premium. I'll send you guys a problem on portfolio percentile problem anyway, so you guys will be able to do that little drill or quiz throughout the week before you take your exam. I'll send the question to Morgan. Yep. So yeah. So if you, so this is a very straightforward exam. If you ask me, just make sure you understand your content very well. You know what formulas you have on the table. Common pitfalls, you try to skip those, and you should be fine. Don't repeat yourself so much on the test. Be in the habit of storing stuff on your calculator as well. So can also save you a ton of time. Any questions? Do you guys have something that you would like me to just talk about casually, or yep, any questions? Okay. But yeah, I think you guys will be fine. So feel free to let me know if you have additional questions. I will send some more problems to Morgan so that you guys can have access to those problems and do it. Again, the protocol would be very honest with yourself. Don't open any textbook or don't use your formula sheet to do this exam, right? Sit down through just 2 hours to complete the exam, and then send the solution script to Morgan, and then that will get forwarded over to me, and then I'll pass on the solution to Morgan to share. And you just basically grade yourself, right? And make sure I will know what you got, because I'm curious to see how prepared you are, really. I'm not gonna give you guys really difficult questions, but it will be very standard. So yeah, cool. I think that's all I've got, and hopefully I'm able to add something to you guys, your preparation. But any feedback?
I'd like to just say thank you for taking the time to do these sessions with us, because I really appreciate it.
Good to hear. Oh, so I know, wait. Yeah, Eva spoke. Chris and Daniel, we've not heard from you guys today. I know Samuel has been also engaged. Chris, any feedback? Or comments, questions? Daniel, same to you. No pressure at all if you don't have one.
Thank you, Sedgwick, for your support. This session has really been helpful. I'll say I'm able to learn so much, and I'm looking forward to putting it to real practice towards the exam and crossing my finger to have exam success. Thank you so much.
Good to hear. Thanks. All right. I don't think I have anything else. So yeah. Morgan?
I don't think she's on anymore. I don't see
Oh,
her.
okay, she's not on anymore. Yeah. Okay, cool. All right, then we can end the session, and then I'll have some side conversation with her regarding passing on some stuffs to you guys. But I wish you all the very best, and on this exam, just be very confident on this is a very normal exam, right? So be very confident. And I'll share this before I go away. So many years ago, when I took 2 exams back to back, P and FM. I did P in July and did FM in August, and I wasn't super ready for the FM component. But hey, there's just one thing that just kept telling me that, hey, just you've covered enough, but I just didn't get to the point that I wanted to feel like I'm 1000% prepared, right? Because I was just doing a back-to-back thing. But hey, what helped me on the exam is the confidence. The second thing was learning to move on when I can solve the problem. So it would interest you to know what I did on that test. I replicated the same thing for exam C, which is the construction and evaluation of actuarial models, now called, we used to be STEM, and has been split into FEM-S and then advanced STEM. For the first few questions, I was struggling, so I started from the very last question, coming all the way down to the bottom. So I clicked on review and started from all over, like the very top and climbed down. It was interesting because the 15 questions towards the end were really easy. And after, like solving those problems, I gathered a lot of like confidence to tackle the tough problems. So I was able to do it, and I passed both exams. But the key thing is move on when you can solve a problem. Don't waste your time, because chances are that there are problems that don't work. And come back to those problems that you skipped, and hopefully you can get 1 or 2 questions on those. But you should be fine. I wish you all the very best, and thanks for joining the session. It's been great. I hope that in future I will be able to do more of this once I graduate from my PhD. So I appreciate you guys joining and learning something. Cool. All right. Feel free to connect with me on LinkedIn as well. I'm on LinkedIn. My name is exactly as it is on LinkedIn. So just feel free to connect, and you can shoot me a message on LinkedIn if you have one about any exam. All right, if there is nothing else to talk about, then guys, I just say I appreciate you guys one more time. So I look forward to hearing your exam success story. All right. I'll go ahead and end the call. Good night, guys.
Good night.
Right.
Job, baby.